for these problems, the question is asking that we take the HBr, which is hydrobromic acid, and that we write the ionization of it when it's placed in water. It's also asking why is it considered an Arrhenius acid. And so let's go ahead and talk about how we show the ionization of it in water. So we start off with HBr. And when it's put in solution, it will dissociate into a hydrogen ion, which is hydronium, plus a bromide ion. Now, the reason why it's an Arrhenius acid is because the definition of an Arrhenius acid is anything that gives off a hydrogen ion in solution. Now, for the next problem, it's asking for us to write the dissociation of magnesium hydroxide when placed in water. And so we're starting with magnesium hydroxide. And when it is placed in water, it will dissociate into magnesium ion, which is a 2+, and hydroxide ion, which, if you remember, hydroxide is just OH, 1-. Now, before we move forward, what is the problem with what I just drew out there? Go ahead and pause the video real quick. I want you to think about what is the problem with what I just did. If you take a look here, the problem is that there's 2 hydroxides over here. What that means is that we need to have 2 hydroxides over here to make sure that it's balanced. And so because there's 2 hydroxides in the compound, it will give off 2 hydroxides when dissociating in solution. Now, this particular question is asking, well, why is this considered an Arrhenius base? This is considered an Arrhenius base because it gives off a hydroxide when dissolved in water. And so Arrhenius acids will give off hydrogen ions, and Arrhenius bases will give off hydroxide ions. Now let's go ahead and talk about how we go about naming binary acids and how we go about naming oxyacids, which are essentially acids that have a polyatomic ion in it. It's actually very straightforward. Binary acids, well, what is a binary acid? It's got 2 elements in there, and if you take a look, this right here is a binary acid because there's 2 elements, hydrogen and chlorine. And so when we are naming them, all we do is we name it hydro, whatever the anion is that's associated with it, which in this situation is the chloride ion, ic. And so it's hydrochloric acid. And so again, that you just fill in whatever the root of the element is. So hydrochloric acid. Another example would be something like this, which would be hydrofluoric acid. So again, notice how it's got the hydro in it. Now for oxyacids, you do not put hydro. It does not have hydro in there. Instead, whatever the polyatomic ion you have, all you do is you change the ending of it to a different ending. And so, for example, if the ending of the polyatomic ion ends in 8, you change it to ic. For example, this right here happens to have chlorate in it, ClO3, which is chlorate. Instead of chlorate, it's chloric acid. And so we would take our chlorate, and instead of chlorate, it's chloric acid. But what if it does not end in 8? Well, for example, this right here is not chlorate, this is chlorite. And so if it ends in an ite, you change it to us. And so, for example, this happens to have chlorite in it, and you take the ite and you change it to us. Chlorous acid. So, pretty straightforward. If it is a binary acid, it's hydroic. And if it's an oxyacid, it means it has a polyatomic ion with it, and whatever the ending of the polyatomic ion is will tell you how you change what you change it to. So if it ends in ate, it becomes ic. If it ends in ite, it becomes us. And a really good way of memorizing that is meningitis, arthritis, hepatitis. And notice how all of those words end in ite, us. So hepatitis. And so it's a good way of memorizing that. So let's go ahead and do some practice problems. This first one here, this is a binary. So because it's a binary, it's hydroic. So it's hydrofluoric. This one is not a binary because it's got more than 2 elements associated with it. And so what that is called, well, ClO is hypochlorous, and hypochlorite. So ClO is hypochlorite. And so instead of hypochlorite, if you look at our rules here, the ites become us, so it becomes hypochlorous. And so we can't forget the word acid as well. So hypochlorous acid, and that's hydrofluoric acid. Now number 3 here, is this an acid? Well, according to the definitions we've learned so far, it does not have a hydrogen ion associated with it. It doesn't have a hydroxide either. This actually is just nitrite. So this is something that we already know. It's just nitrite. NO2 minus is nitrite. Now let's go ahead and skip on to 8. Let's take the name and go to the acid, or the name to formula. And so if you take a look, it's sulfuric acid. And so what is sulfuric acid? Well, where does the ic come from? The ic comes from 8. So that means that it has sulfate in there, which sulfate is SO4 2-. Now, because it's an acid, it's going to have some hydrogens with it. However, it's not just going to have one hydrogen, because what is the charge that it has? It has a 2- charge, so that means it's going to have 2 hydrogens with it, because each hydrogen is a 1+. All right, let's go ahead and move on to the next one here. So this is phosphoric acid. Phosphoric acid, again, the ic comes from 8, so that means it has phosphate, which is going to be PO4, and it's a 3-. And so this is going to end up having 3 hydrogens. And that is phosphoric acid, because it has phosphate in there, and it has a 3- charge. It's going to have 3 hydrogens. Now, what about number 11? Well, number 11 is hydrobromic acid. What's telling us that it's a binary acid? Well, it's got hydro in there. If you ever see the prefix hydro, that means it's a binary acid. That means it's going to be a hydrogen plus one other element, which bromic is bromine, and so it's going to be HBr. And so just keep in mind that whenever there's a hydro in there, it has to be binary. Go ahead and complete the rest of these practice problems. You'll be able to find the key on my website under the booklet key. And if you have any questions, feel free to email me.